Hello Math SL students, and here a look at not all, some of the questions of the test on differentiation. So I'm just going to highlight a couple which I think are of interest. The format is as before. I'm simply going to talk my way through it, giving you hopefully some insight on how to tackle these questions, or at least get an insight of how I would tackle them. All right, so let's have a go. Unedited. There we go. All right, so question number one, the function is x to the power 3, evaluate, so find a number of this when h is equal to that. Okay, so I can use my GDC. So what I really want is I want to find 5 plus 0.1 cubed, because that's the function, minus 5 cubed over 0.1. So I'm definitely going to do that with my calculator. That's way too complicated. So let's see. Like some brackets, 5 point, and that was a cubed, minus 5 cubed, which is of course 125, but I'm using my calculator anyway. Make sure my brackets, no. Okay. Delete. Brackets closed, and that divided by 0.1 is 76.51, but 3 sig figs. So this is roughly 76.5. Good. So what number does it approach when h goes to 0? Well, so this is the derivative of x cubed, which is equal to 3x squared, and evaluated at 5, right? So this is 3 times 5 squared, which is 25. 75, 3 times 25, and that kind of makes sense. 0.1 is quite large, but it's relatively close to 75 as it should be. All right, good. Let's have a look at the next interesting question. Question 2 is boring. Question 3. All right, find what I'm. Okay, so this is the mother function, and this is the derivative function. Okay. One has already been given, so let's just see if I understand this. This is a quadratic. So the derivative is linear. I'm going down, I'm going up, so that must be d. Good, that makes sense. All right, number 2. I'm stepping down, probably going through 0. So this looks like there's only one function, so that is this one, right? So it's always negative except there. So this must be e. Okay, what about f3? Oh yeah. I got 3 zeros, and then I go from negative to positive to negative to positive. So 3 zeros. Well, there's only one with 3 zeros, and let's see, signs negative, positive, negative, and positive again. So that must be B. All right. So F4 is a straight line. So the grain is constant. So horizontal line. So A or C, they're both. All right, but of course I'm stepping down, so it has to be negative. So my horizontal line has to be below the x-axis. So this must be equal to, what does it say? A. All right. A. Good. That makes sense. All right. Good. Let's see. Oh, boring. This one, the last one was interesting with this one, I'm pretty sure. All right, so I've got this one. Better remember that sine squared of x is sine x all squared. Okay, so I've got a sum rule there, and I've got sort of like a chain rule over here. So let's call this y. Then dy by dx is equal to dy by u times I du by the x, u is equal to sine x, means that u prime is equal to sinus positive cosine x, and then y is equal to u squared. Therefore, y primed is 2u, well, not y primed, dy by the u. So therefore, dy by the x is equal to 2u, and u was sine, so 2 sine x cosine x, and I definitely see a double angle formula, so that is sine 2x. Okay, good. So f prime of x, so I've got cosine of 2, which will be 2, and I've got a 3 out in front. Cosine is negative sine, so that becomes negative sine 2x, and then plus this sine squared, so plus sine 2x. This becomes minus 6 plus 1, which is minus 5 sine of 2x, which is indeed what I should have gotten. All right, good. What about this one? In the interval of pi by 4 to 3 pi by 4, one normal to the graph has an equation x equals k. All right, so let's have a look. X equals k means that if this is the xy coordinate, then it is a vertical line, and if this is the normal, that means that the gradient must be horizontal. So if this is the normal, this must be the tangent line. Right, so the tangent is horizontal. Is tangent horizontal means that the gradient is 0, which means that I've got a stationary point. Stationary point. Perfect. So stationary point, which means that f primed of x is equal to 0. So f primed of x is equal to minus 5 sine 2x, which is equal to 0, which means that sine of 2x is equal to 0. So sine is the y coordinate on my unit circle, so the y coordinate is 0 at 0 degrees, but 0 degrees is not included. And pi, so if x is between 3 pi by 4 and pi by 4, that means that 2x is in between. That'll be 3 pi by 2. Oh, that was 4 and pi by 2. So this will definitely have a solution of pi, because that's where the y coordinate is 0. So that's it. X equals pi by 2, which must be equal to k. Interesting question. All right, good. Let's see if I can find another interesting question. That was boring. Oh, this one is kind of cool. This is very cool. So let's have a look. Let's start with my first derivative being 0. So that means I got a stationary point where at x equals 0. Right. And my second derivative is positive. So I have a minimum. I'm looking up. And where 0, minus 1. So I've got a little minimum there. Fine. On the left of this, I'm a decreasing function and I look upwards. I'm decreasing and I look upwards. On the right of this, I am increasing and also look upwards. My second derivative is 0 there, and the concavity changes. So this is a point of inflection, but I keep increasing. All right, good. So I've got a concave up, a minimum, concave up, concave up, concave up, and then concave down, but I'm increasing. All right, so this is a terrible job. Let's try it again. All right, so I am minimum and change of concavity. Fine, that makes sense. Good. Yeah, minimum, I'm decreasing, I'm increasing, I'm concave up, I'm concave down, point of inflection, and a minimum. Good. Is there any other question that is interesting, worth looking at? Oh, that looks terribly boring. Okay, this one looks nice. Is this one nice? Oh, well, let's do this one over here. All right, so the x-intercept is a question when the axis for f of x is 0, which is x into x minus 4 squared. Therefore, either x equals 0, meaning the first is 0, or x equals 4, that means the bracket is 0. Notice that is a repeated root, so I'm only touching the x-axis. Find the coordinates of the maximum point, so that means that the first derivative is going to be 0. So what do I have? I've got x minus 4 squared plus 2x x minus 4. I got x minus 4 common, leaving me 1x minus 4 plus 2x, so that's going to be x minus 4 and 3x minus 4. So this is going to be 0 at x equals 4 and 4/3, right, the maximum point. Now this is a cubic function, so, and the coefficient is of the x to the power 3 is positive, so it's gonna be like this. So my maximum point is gonna be to the left of the minimum point. So this is my maximum point. Now I need to find a coordinate, so I need to find a y value, so I need to substitute that into the function. F of 4/3, which is 4/3 into 4/3 minus 4 squared. So this is going to be 4/3. So this is going to be 4 minus 12 is going to be minus 8/3 squared, which is, let's say, 64 times 4 is 256. 39 and times 3 is 27. All right, so my coordinates are 4/3 256/27. Of course, I could have used my calculator for this as well, but whatever, it doesn't matter. I've done it. Points of inflection, that means that the second derivative is going to be equal to 0, right? Right, so second derivative of x. So, you know what, I'm gonna multiply this out because I think I like that more. Do I like that more, or do I do the product rule? The product rule is kind of simple, right? Because this is a two linear function. So let's do the product rule. So the derivative of x minus 4 is 1, leaving me 3x minus 4, plus the derivative of 3x minus 4 is 3, so 3 into x minus 4. Right, so this is 3x plus 3x is 6x. 3 times minus 4 is minus 12. No, 3 times minus 4 is minus 12. Minus that is minus 16. So this is equal to 0 when x equals to 16/6 or 8/3. I need to find the coordinates of that again. So I need to evaluate this f at 8/3. Let's do the calculator for now. Let's see if that works. Okay, so I've got 8 divided by 3 times 8 divided by 3 minus 4 all squared. Right. Let's see if can you put it in a fraction for me? All right, good, nice. 128/27. Okay, so 128/27. Therefore, my coordinates are 8/3, 128/27. Good. Use your answer to sketch the graph of the curve. Okay, so I need to clearly indicating the features you found. Okay, so what's the features I found? I found the x-intercepts. I found a maximum at 4/3, so it's about 1.33, and the inflection at 8/3, which is what, 2.67 or something like that. Okay, so and I've got, okay, good. So stay within the domain. So I've got a 0 over there. I've got a 0 over there. Actually, I know what interesting 0 that is, right? So that's the one over there. So it is not symmetric. So I'm going up. Then I have a maximum, and then I change concavity. So this is 4/3, 256/27. And so that's 1.3. This is, there is a point of inflection, 8/3, 128/27. Right, so did I have it? I got my zeros. This is 4, this is 0, this is 1, this is 2, this is 3. 4/3 is my maximum. Point of inflection is there. This would be my minimum, actually. Might as well put it in. Minimum, maximum, and an inflection point. Right. Done. Good. Okay. All right, students. So I think these were sort of the more juicy of the questions. Hopefully this will help as you go over this and you prepare for the end of your exam. All right. Success and enjoy.